Olds elevator tabletop demo model. Fixed screw, does not turn, rotating casing with intake scoops. Testing today some Alpha Drive. Material from Shepherd Paper. Seems to elevate pretty easily. We have some, I guess these are ground up corn cobs. Like the paper, they move pretty easily. You can also get an idea of how the elevator can be used as a feeder. You look at you get a discrete amount of material for every revolution. You control the RPM of the casing, you control the feed rate. We're here at Olds Elevator this morning. We're going to do a couple of trials for Shepherd Specialty Papers. We have samples of Alpha Dry, which is a paper product, and some corn cobs, ground up corn cobs. This is the Olds test elevator. It's a 4-inch diameter rotating casing. Air intake scoops at the bottom. This is held in, the casing is held in place by a couple of bearings. We have a discharge head, which we'll look inside the discharge head. Turn the elevator on. Here you can see the casing turns, but the screw does not. There's a static screw. The elevator is empty at the moment. We'll put some material in it and give it a try. This is our feed hopper. We now have put some corn cob in our machine, and we're going to give it a test run here. Running at 15 hertz. See how the material itself feeds. Let's get a look in the top of the elevator, catch it coming out. I'm just going to recirculate for the moment. Here comes the material. Recirculating. There's a lot of dust in this material, but all the dust is coming out as it falls. Handles pretty easily. Thought we would experiment a little bit with changing the flow rates. And I've got my hand on the VFD at the moment, raising and lowering the hertz. Right now we're slowing the elevator down. You can see how just by changing the rotational speed of the casing, you change the delivery rate. I'll speed it up now. When you stop the elevator, it remains full of material. Ready for your next dose. More corn cob and turn that discharge spout around so we can demonstrate how we're running at 15 hertz here. This is how we can demonstrate how the material get a smooth, steady discharge at any speed. Again, this material is loaded with dust, and so it's, however, if you look in the top of the elevator, you see no dust coming out of the top of the elevator. That's all entrained in the material. And again, the elevator stays full of product. All right, we're going to empty out this corn cob and put some paper in. I'm going to run some paper now. Run it forward. Stop that so I can catch it coming out of the top of the elevator. Put the camera. You can see here's the feed hopper. Machine's taking the paper, looking in the top of the elevator, and there it comes. We'll stop it and see how it behaves in the head. Interesting. We may need to put a little bridge breaker on this to ensure reliable feeding at the intake scoops. Do a couple more trials and I'll install a bridge breaker to show you what we're talking about there. No, maybe not. I think we're okay. Put a little bit more paper in there and play with some speed. We're running at 15 hertz at the moment. I'm going to slow the elevator down just to observe. Let's see if we stop the elevator remains full of material. Restart. Stop. Start. Now we'll change the speed her up a little. Stop. Now you could put a programmer on it to fill fast and trickle feed. Very accurate. See what's going on in the hopper. Speeding okay. I think we will need a bridge breaker. I'm going to make that adjustment. I'm going to mount this little steel bar attached to the rotating intake scoops at the base, and use this as a bridge breaker to break up bridges in the hopper. Breaker installed on the elevator. Put it back to recycle mode. Should put it in forward. Yeah, that's a lot better. I'm gonna put that a little more material in. Let's see here. Yeah, that feeds a lot better. Probably want to use a little larger capacity discharge head, possibly with a steeper angle than we have here. I think this material is backing up in here, but that's a simple design change. We've just switched our discharge tube, so we'll put the material in the bucket. Interesting how these little fibers are clinging to the copper. Static electricity coming from the plastic tube. Now we're starving the intakes because we're out of material.